Hey guys, today we're going to jump right in with lesson 2 in Algebra 1. And we're going to begin the warm up. Once again, I'd like for you to pause the screen and try these problems. Okay, so I hope you've paused and you've got some answers. Remember, a negative times a negative is a positive. The same thing with division. A negative divided by a negative results in a positive. So we have positive 30, positive 9. This negative times this negative gave me a positive 10. A positive 10 times 3 is a positive 30. Then we have a positive divided by a negative, which results in a negative. And then we have number 5. It says a team lost a total of 12 yards on 2 plays. What was the average loss per play? So they're losing 12 yards over 2 plays. So we know 12 divided by 2 is 6. So that's an average loss of 6 yards. And you may be saying, well, why didn't you put negative 6? Because the word loss takes care of that negative. I don't need to say they've lost negative 6 yards. We don't say that. We don't talk that way. They lost 6 yards. We know that it went backwards 6. So jumping into today's lesson, we're going to be looking at some algebraic expressions. So we talked about numeric expressions yesterday or in the previous lesson, maybe that was last week, whenever. But in our numeric expressions, there were only numbers included. So maybe you can kind of guess what algebraic expressions means. So we're going to look at this problem here. It says concert ticket sales. The average price of a concert ticket in 2014 was $82.07. In 2014, concert ticket sales revenue in North America amounted to $6.2 billion. About 20% of Americans attend a concert in a given year. The largest audience for a concert was about 4.2 million people at Copacabana Beach in Rio de Janeiro. Sounds good, doesn't it? Rio de Janeiro, Brazil, on New Year's Eve, 1994. I just think a beach sounds nice. And a concert. I haven't been to a concert for a long, long time. Don't know when I'll get to go to one again. The longest concert by multiple artists lasted for 372 hours and 10 minutes. It was held in Las Vegas, Nevada from October the 1st, 2014 to October 17th, 2014. Whew, a 16-day concert. Acts came from all over America and Ireland to perform as part of this record-setting concert. So you get the idea. We could keep on reading all of these and keep on going and keep on going. But what this is doing, it's setting up word problems in which we're going to need algebraic expressions to solve. So let's look at it. I've got today's standards on here. I'm not going to take the time to read through these, but if you would like to, they're there for your reading. And today's vocabulary. Once again, I'm going to put these on here. You can pause the video, write them down, or get in your workbook and highlight these definitions, but you need to know this vocabulary. This vocabulary will be tested, and it is important. If you don't understand what the question's asking because you don't know the vocabulary, then you're not going to be able to do the questions. So it's important to know and understand this vocabulary. So let's jump in and figure out how to write algebraic expressions. Sometimes we have algebraic expressions containing multiplication. Sometimes they contain division. Sometimes they contain addition or subtraction. The main thing to realize is that when it's an algebraic expression, there's going to be a variable in it. The variable is these letters, G, X, M, C, D. Variables are letters that represent an unknown number. Or in this case, it says a variable is a letter used to represent an unspecified number or value. So an algebraic expression is all of it put together. An algebraic expression is an expression that contains at least one variable. If it didn't have the variable in it, then it wouldn't be an algebraic expression. It would be a numeric expression. So we've got algebraic, has to contain at least one letter or one variable. Terms are separated by pluses and minuses. So we only have one term here. 4g is one term. The 0.5x plus 2, this is two terms. It's separated by a plus. And then this 3 plus m over 7, once again, it's two terms. Terms are separated by plus signs and minus signs. This, you might be a little bit confused and think, oh, that's two terms, but it is not. It is one term because it is not separated by a plus or a minus. That's a multiplication sign. So when I multiply two things together, C times D, that's one term. C times D plus something else would make it two terms. And then here, of course, we have two terms. It's separated by this plus sign. This 8yx is my first term, and 6ab is my second term. A variable term, it's pretty simple. It's a term that contains a variable. So 4g contains the variable g, so that's a variable term. 0.5x contains the variable x, so that's a variable term. But if you look at just the 2 is a term, but it's not a variable term because there's no letter in it. And then we have our constant terms, which do not contain variables. It's just a number by itself is our constant. So in this example, we've got the constant 2, and in this example, we have the constant 3. So let's jump in and look at some problems. Begin solving. This is the fun part, or combining like terms. So we've got the concept here is interpreting an algebraic expression. We've got some more words for addition. More than, sum, plus, increase by, added to. It's important to know that these words mean the same thing as add. The sum is the answer to an addition problem. If I say I have $5 more than Jackie, then whatever Jackie has plus 5 gives me what I have because I have $5 more than her. Subtraction, we've got less than, subtracted from, difference, decreased by, minus. All of these things mean the same thing as subtraction. And of course, multiplication is the product, multiply, times, doubled, tripled. We know that those things imply multiplying by 2 or 3, quadrupled, times by 4. Division, another word for division, we might say divided by, or we might say broken into groups of 3. If I have 6 broken into groups of 3, we know that there's going to be 2 groups with 3 in each group, or 3 groups of 2, however you want to look at that. I can't remember now even how I said it. I should write down things as I say them. Verbal expression for 5x cubed plus 2. So we've got 5 is being multiplied, this cube of x cubed, and then we add 2. So how could we write this? We might say 5 times x cubed plus 2, or we might say the product of 5 and x cubed increased by 2. There's so many different ways that we can say this. But simply said, 5 times x to the third power, or x cubed, those mean the same thing, plus 2, or increased by 2. That is a way that we would take this algebraic expression and write it using words, making it a verbal expression. Okay, example 2 in your workbook. I hope you're following along in your workbooks. If not, I hope you're taking notes if you haven't got a workbook yet. Write a verbal expression for a to the little 4 plus 6b divided by 7. We know a in that little 4 means a to the 4th power, increased by or plus the quotient. Quotient is the answer to a division problem. So we've got the quotient of 6 times b all over 7, or divided by 7. The quotient of 6 times b and 7. An alternative method would be to say something like a to the 4th power plus 6 times b divided by 7. So the difference here is when we use the quotient, we just said 6 times b and 7. But here we didn't use the word quotient, so instead we said 6 times b divided by 7. Okay, let's look at our third example. In our third example, it says tap to see how to write an algebraic expression for each verbal. 2 times the quantity y plus 11. The quantity means that we've got to have that whole thing. We've got to have that whole sum. So anytime I read the word quantity, I immediately think, put in those parentheses. So I've got 2 multiplied by that entire quantity, y plus 11. N cubed increased by 5. What do you think? N cubed increased by 5. We know we're going to have n raised to that little tiny 3 plus, increased by means plus 5. Should look something like this. And the fact that we have an addition problem, we can change the order of those because that is the commutative property. The commutative property applies in addition. So we can change the order. That's what the commutative property is, changing the order. We can say n cubed plus 5, or we can say 5 plus n cubed. We're going to get the same answer. 1 minus the quotient of r and 7. I know quotient implies the answer to a division problem, so this must be divided. R over top of 7, or r divided by 7. And it's 1 minus that quotient, so 1 take away r over 7. There it is. And be sure to watch out. A lot of times I see that people will put the quotient of 6 and t. They'll put it backwards. They'll put t over top of 6. But the quotient of, right here it says the quotient of r and 7. What comes first goes on top, r over top of 7. The quotient of 6 and t means that 6 is over top of t. The quotient of t and 6 means that t is over top of 6. So the first term goes in the top, or the numerator. The second term goes in the denominator, or the bottom. And then we've got D. Go ahead and click on it. The product of p and 6, that just means we're multiplying, so I've got 6 times p. Okay, example 4, we're going to write an expression yet again, but this is our word problem. Don't think word problem. Ugh, think word problem. Woohoo, I get to read in math class. Yay. When writing an expression to represent a situation, choose a variable to represent each unknown value in the problem. This is called defining the variable. It's important to define your variable so that somebody can just pick up your work and know what the heck you're talking about. Soccer. This problem has to do with soccer. So in the group play stage of the FIFA World Cup, teams are placed into groups of 4 and they play each other. A team is awarded 3 points for a win, 1 point for a tie, and no points for a loss. Write an algebraic expression that represents the number of points accumulated by one team in the group play stage of the World Cup. We don't know how many times they're going to win, right? So let's let W represent the number of wins. And we know that they get 3 points for a win. So that's why they said, okay, 3W for the win. Plus they get 1 point for a tie. So we need to define the number of ties that they're going to get. We don't know how many times they're going to tie up the game. So ties is an unknown. So let's let T represent the number of times they tie. And then, of course, Z is the number of losses. If we follow along here, do we really even care about losses if we're adding up their points? Not really, because they're getting 0 points if they lose. So who cares if they lose? But since it asks us to define the variables, we're going to say Z is the number of losses. So the number of points awarded for win is 3 times the number of wins. The number of points awarded for ties is T. 1 times T would just be T. And the number of points awarded awarded for losses is 0 times z. So we can simplify this and just say the number of points accumulated is going to be 3w plus t. Notice we didn't include that 0t because 0z, because 0 times any number that we put in there for z, if they lose 100 times, they get 0 100 times, so it's still going to be 0. All right. Let's take a minute to do the check in your workbook. I would like for you to try these, and then maybe we can go over any problems that you had. This is in your workbook, so complete the lesson check in your workbook. I will be checking those. Let's explore using algebraic expressions in the real world. It says Ruby is a waitress at a local diner. To save time, she uses abbreviations for the items on the menu when she takes customers' orders. That makes sense. You're not going to want to write everything out. Burgers, she represents B. Fries is represented by F maybe. Chicken tenders, probably CT. Salad, S. Water, W. Juice, J. I don't know how she does it, but that would be how I would do it. So let's look at it here. It says she uses the first letter of the menu item instead of writing the entire item. For example, if a customer orders a salad, Ruby writes S. Look at Ruby. She's on the same page as me. We're thinking alike. The letters that she uses to represent items are called variables. When multiplying and when multiple variables are combined to write an order, we get this algebraic expression. So I'm just going to look at this order 1 here. 2 times B. 2 times the number of burgers. They must have ordered 2 burgers, right? They ordered maybe a chicken tender and then 3 waters. Well, we know that a water is $1.75. So if they ordered 3 waters, then we've got to multiply 3 by $1.75. If they ordered a chicken tender, only 1, then we know that that's $3.25. They ordered 2 burgers, so they're paying $2.75 2 times for those burgers. So 2 times $2.75 plus $3.25 plus 3 times $1.75 is going to give us the total. Order number 2 says 5 times S plus J. So they must have had 5 people at that table that ordered a salad and a juice. So if we add the price of a salad and a juice together and then times it by 5 people, that's going to give us our total price for that order. All right. Let's look at this. We're going to look at the substitution property. That's what I just did in this previous problem was an example of the substitution property. She let B represent the price of burgers, and then she went back in when she went to calculate the people's total for their bill and plugged in how much a burger cost. She substituted in the value for the burger in place of that B. That's substitution property. So it says a quantity may be substituted for its equal in any expression. If A equals B, then any place I have an A in the problem, I can replace it with a B. Or if I have a B in the problem, I can replace it with A because they are equivalent. They're equal to each other. So any time that I have 2 equal values, I can replace them with each other in the equation or in the expression. So if M equals 11, then if I have 4 times M, then I can replace that M with 11, and I know that 4 times 11 is equivalent. It's the same as 4 times M since M is 11. Okay, so up here it tells me that P equals 6, Q equals 0.5, and R equals 10. So 3P is the same as 3 times what number? Of course, it's going to be 6 because P is equivalent to 6. Q squared is the same as, well, Q is equal to 0.5, so we replace or substitute that Q with 0.5 and then square it. 4Q plus R is the same as 4 times Q, which is 0.5 again, plus R. R is the same as 10, so I'm going to substitute in a 10 in place of R. PR cubed. Well, P is 6, so I'm going to substitute 6 in place of P. R is 10. I'm going to substitute 10 in place of R, and I cube it. We can check our answers. Woo woo. Your teacher got the answers right. That's good. It'd be pretty bad if I didn't, wouldn't it? So now let's try example 5. Take a second, pause this, and I want you to try to do it without me holding your hand and walking you through it. You try it. After you've finished the problem, unpause, and I'm going to go over the answers. Says, evaluate a squared times 3b minus a plus 5 divided by c if a equals 2, b equals 6, and c equals 4. So we're going to have to do a couple things in this problem. First, we're going to have to use that substitution property we just learned. Anywhere I have an A, I'm going to substitute it with 2. Anywhere I have a B, I'm going to substitute it with 6. Anywhere I have a C, I'm going to substitute it with 4. Then we have to follow order of operations, which we learned in our previous lesson. So we're applying everything that we've learned up to this point. We plug it in. They've done that. So now order of operations tells us to go to parentheses. We've got to take care of parentheses first. Inside that parentheses, then, I've got to take care of the multiplication first. So 3 times 6 is 18. Still have to work inside that parentheses and solve. So next I'm going to do the 18 minus 2, and I get, what is 18? Take away 2. It is 16. Then I add 5. 16 plus 5 is 21. So we simplified that. Parentheses. Next we're going to take care of what comes after parentheses? Exponents. Take care of that 2 squared. 2 squared is 4. So now I have 4 times 21 divided by 4. Order of operations says go in order from left to right. 4 times 21 is 84. Then I divide by 4 and I get 21. So my answer is 21. And we are done. All right, let's look at some common errors. I like to look at these because if I know that somebody else is always making a mistake, then maybe I can learn from it and I won't make that same mistake. And remember, I talked about this in class, and I realize this is backwards to how you would read it. But look up here, making mistakes. It's okay to make mistakes. Mistakes is a part of math. The example that I gave in a few of the classes is, if you make a mistake and you speed on accident, you get a speeding ticket and you get punished. And we live in a world where we think mistakes are bad because a lot of times you make a mistake, you get punished. Math class is not one of those cases. I'm not going to be walking around with a ruler cracking you over the head if you made a mistake. Mistakes are good in math class. Mistakes are part of the process. It's how we learn mathematics. I like if you're making mistakes as long as you analyze and fix those mistakes. We learn from mistakes. I was recently helping my nephew with an online assignment and we made a mistake and he was mad at me because we made that mistake. And I went back and I showed him, we learned from it, we corrected it. And I told him, I said, even your Aunt Leah, the math teacher, makes mistakes. It's part of the process. And you know what? I guarantee you, we were looking at least common multiple. And for whatever reason, I did greatest common factor instead of least common multiple. And I told him, I said, you'll probably never, ever forget that again because you got so upset over that being wrong. And that's how we learn in math. You will make some mistakes. And as long as you analyze and fix those mistakes and figure out what you did wrong, usually those are the things that stick with you the most because you do get upset because it was wrong. And then you can fix it and learn from it. So if we look at this person's mistake, they plugged in the 2, the 6, and the 4. That looks good. They did their multiplication. That looks good. Then they went ahead and did -2 plus 5 and got -7. -2 plus 5 is not -7. 2 plus 5 is 7, but they didn't look at that negative or that minus in front of it. So they made a mistake right there. They just looked at the 2 as a positive 2. But when you look at that 2 by itself and it has a negative or a minus in front of it, then you have to include that with it. That minus then becomes a negative when I zero in on that term. So that is a negative 2 plus 5. So they should have got 3 instead of 7. So then they got the entire wrong answer. All right, so let's look at example 6. In 2004, Chad Fell set the record for the largest bubblegum bubble blown. Assume that the bubble was spherical, meaning it's round like the earth, like a globe, it's spherical. The surface area of a sphere is 4 times pi, we know pi is roughly 3.14, multiplied by the radius squared. Now let's think about that. 4 times pi. So we know 4 times pi is just the same as 4 pi. We can write them side by side, 4 pi. Multiplied again by the radius squared. So we have to square that radius, then multiply, I've got the hiccups. Probably all this talking. So let's let R equal, what would make sense for R to equal? The radius, right? So R equals the radius, so we have 4 times pi times the radius squared. Remember I told you in our previous lesson, we don't really use x anymore in algebra for multiplication because x is now a variable, it's an unknown. So I prefer that you write it like this, 4 pi r squared. So part B says the record-setting bubble had a radius of 25.4 centimeters. So find the surface area of this bubble. So we're going to take that 25.4, and since it's the same as the radius, and we let R equal our radius up here, we're going to plug it in place of R. Order of operations tells me to take care of my exponents first, because there's nothing to simplify inside parentheses. So I square that 25.4, and I get 645.16. Then I just multiply 4 times pi times that number, and I get 8,107.32. Little study tip here. Assuming that the bubble was spherical allows us to use the formula for surface area to estimate the surface area. So we know the bubble probably wasn't an exact perfect sphere, but this allows us to come up with a reasonable estimate because we do know that bubbles are pretty round, maybe not exactly round, they might be a little oblong, but it gives us an estimation. All right, go ahead and do your lesson check again. And once again, we will look at these answers when we meet together in class. Make sure that you are getting them correct. And I would like for you to take a second to do this exit ticket. What does it mean to define a variable? Think about some problems here where we defined a variable. Write a problem and define a variable, and how did you decide which variable to use? I'm going to put a little Google Doc, a working Google Doc, and I want you guys to add your answers into this. I will assign it to you. So go ahead and think about this, and then we will discuss this again in class, but I will be looking at your answers and you will get credit for participating in this. All right, that's all I have for today.